All right, let's look at the derivatives of inverse hyperbolic functions. All right. To be honest, I don't. Sometimes I don't even remember these guys, but I know how to derive them, so it's not going to be a problem. All right. So we have the derivatives of inverse hyperbolic functions, and the way you derive it is exactly the same for all six of them. So I'll just pick one of them and try to demonstrate you can actually derive these things. All right, so I forgot to number these, so maybe I'll number these 1, 2, 3, 4, 5, 6. All right, let's see. Let's try to do maybe number 5. Might be challenging enough. So you have a proof of number 5. All right, so let's do that. All right, so we want to find, so the derivative of this guy, I'm going to call this guy y is equal to inverse hyperbolic secant of x, right? So we don't know how to deal with the, inverse hyperbolic function yet. So I'm going to apply hyperbolic secant. So you have hyperbolic secant of y is equal to x. All right, now we're going to use the implicit differentiation to take the derivative. So we're going to take the derivative with respect to x. All right, so derivative of a hyperbolic secant is a negative hyperbolic secant and times hyperbolic tangent. But by chain rule, you have to multiply by derivative of y. So I'm going to call it y prime, which is what we're looking for. And the derivative of x is just going to be 1. Right? And so y prime is what we are after. So I'm going to divide through by negative hyperbolic secant of y, hyperbolic tangent of y. All right? So we're going to get y prime is equal to negative 1 over hyperbolic secant of y, hyperbolic tangent of y. Right? And we already know that, let's see, hyperbolic secant of y is x, right? So this is actually just x. And using the hyperbolic identity, if you remember, you have a 1 minus hyperbolic tangent squared of x is equal to hyperbolic secant squared of, oh, actually, maybe I should use y in this case, because so this is, we have that. And instead, we want, hyperbolic tangent. So I'm going to just swap these two guys around to get 1 minus hyperbolic secant squared of y is equal to hyperbolic tangent squared of y. Right? So if you want the hyperbolic tangent, and I'm going to just take the square root of both sides. So you have a square root of 1 minus, but the hyperbolic secant is x in this case, right? So you have x squared is equal to hyperbolic tangent of y there. All right, so you can see that we can put this guy right here in here to get, so this is going to be equal to 1 over x and square root of 1 minus x squared. All right, so that's how we got the number 5 there. Right? And the other 5, derivatives can be found almost exactly the same way. So I'll let you guys try that. But I don't expect you guys to memorize these guys. If anything, I'll provide the list of these derivatives. All right, that's it. I hope that this was clear.